Let's begin with p-n junction. P-n junction diode consists of a sandwich of p-type and n-type semiconductors. Rather than two separate pieces of doped silicon being joined, a single sample of intrinsic silicon is treated first with a p dopant, then with an n dopant. Metal contacts are coated on each region, so that wires can be attached, as shown in an animation. The boundary between the p-type and the n-type regions is called the junction. The resulting device, which is made by p and n type of semiconductor material, along with a depletion layer, is known as p-n junction diode. As we see in an animation, the free electrons on the n side of the junction are attracted to the positive holes on the p side. The electrons readily move into the p side and recombine with the holes. Holes from the p side similarly move into the n side, where they recombine with electrons. Now, we explain the formation of p and n-type material. First we see formation of p-type material when small amount of trivalent impurity, such as aluminium, is added to semiconductor-like silicon. Resulting crystal forms p-type semiconductor. As we see in an animation, trivalent impurity atom, aluminium, is added in a crystal of silicon atoms. Impurities such as aluminium and boron remove free electrons, so that the resulting material has fewer free electrons than before. Each missing electron within the crystal structure is called a hole. So in a p-type material, holes are the majority charge carriers. Now, we are going to discuss about formation of n-type material. When small amount of pentavalent impurity is added to semiconductor, resulting crystal is n-type semiconductor. Impurities such as arsenic and phosphorus add extra free electrons to the material. In n-type material, electrons are the majority charge carrier. In p-n junction diode, the holes and electrons are uniformly distributed throughout the volume of the p-type and n-type semiconductors respectively. As we see in an animation, when semiconductors of p-type and n-type are brought together, electrons and holes migrate across the junction. Due to this, depletion layer is formed. In the depletion region, equal number of impurity atoms is involved on each side of the junction. However, the thickness of depletion layer depends on the amount of doping on each side. Here, we are showing the symbol of p-n junction diode. Next we discuss characteristics of p-n junction diode. A semiconductor diode's voltage current, or VI characteristic curve, is described to the behavior of the depletion layer, which exists at the p-n junction between two semiconductors. First, we explain the forward bias characteristics. In forward bias, we connect positive terminal of the battery to anode, and negative terminal to cathode of diode. In the forward bias condition, the depletion region is reduced in width, and the barrier potential progressively disappears, as the applied bias voltage is increased from 0. As we see in an animation, voltage is increasing, Due to change in voltage, the size of depletion layer also change. At a certain voltage level, width of the depletion layer is almost negligible. This voltage is called the forward bias voltage. For germanium, this forward bias voltage is 0.3 volt. And for silicon it is 0.7 volt. At this voltage range, PN junction diode is said to be in forward bias condition, and it acts as a switch. Next is reverse characteristics of PN junction diode. In reverse bias, we connect negative terminal of the battery to anode, and positive terminal to cathode of diode. In reverse bias condition, the width of the depletion layer gets increase as the voltage increases in the reverse direction. At certain voltage level, such as -30 volt, a very small amount of current is flow. Here, we are showing the forward and reverse characteristics of PN junction diode in a graph. Here, we show the working of PN junction diode. If a diode is connected in a forward bias condition between a battery and a bulb, then in this configuration, the diode works as a close switch, and current is flow from battery to bulb. Due to this, bulb glows. But, in reverse bias condition, diode acts as an open switch, and it blocks the current flown from battery to bulb. In this condition, bulb does not glow. For more information, please visit our website www.scientechlearning.com.